Okay, so good morning. Today we are going to look at the fourth and last session on the elements, on the arcane elements, and this one is related to Earth. So Earth, in the interpretation that I'm making of the elements in respect to the city, or this kind of revision of natural cosmologies within the city, within the human-made environment, is related to biomass, to green stuff in cities. So what I would like to do today is to talk about a number of issues that have come up in the last few years, mostly related to green, what we can call green infrastructure in cities, or the integration of vegetation and greenery as an integral part to the city. I mean, we are talking all the time in the seminar as the posthuman city, in a way in which the city becomes again integrated in the ecologies of nature, in the cycles in the natural cycles. And so in this session we are going to talk specifically about the living stuff that populates the city also. So Earth is a complex substance that incorporates topography but also humus, the bioactive layer of the soil, and it is related, or it could also be related to notions such as carbon footprint, which establishes equivalences between land measuring units and their capacity to produce energy from sustainable sources. For example, we have talked about this yesterday, but also to the capacity that Earth has to absorb carbon, which is the main constitutive element of vegetation, and perform within hydrological cycles. So again, we go back to water as a kind of integral component of the city. I would like to recall some of the concepts that we have already seen. For example, the surface energy budgets from geophysics and microclimatology to architecture can account for this relationship between land, hydrology, energy, and airflow. Biotechnologies, urban farming, hydroponics, algae cultures do have also the ability to produce food, to produce biofuels, and even to light cities. And these are some of the fastest growing technologies within urban applications. Green building envelopes, for example, roofs, walls, are capable not only of increasing the building's albedo, as we saw yesterday, but also to retain natural humidity in the urban microclimate, absorb carbon dioxide, produce oxygen, and reduce the heat island effects. These technologies have yet to be incorporated into buildings. I mean, we know now that these technologies exist. They are becoming increasingly common in architectural uses, and in a way, what I would like to propose to you is that the systems that operate on the surface of the Earth can also operate on the surface of buildings, on the surfaces of almost as if this idea that we were looking at yesterday of the surface of the Earth becoming more corrugated can also become more vegetated, become part of the bioactive layer of the city. Let me start with one theory which I really like, and it's a theory that cannot be easily proved or tested. It's a theory from an anthropologist called Jared Diamond, who is originally British but works in California, and wrote a book, a very famous book, almost like populist book, that is called Guns, Steel and Germs. Do you know that book? You know that book?
I've written it.
You've written?
No, right.
I thought you were kind of a ghost writer of Jared Diamond. I said, wow, that's impressive. So this is a theory that is called the theory of continental axis, and it is. I mean, in some ways, it's not specific to this session. I mean, it's maybe more specific to these sessions than to others, but and it's the best argument I have found. I mean, I've already told you I'm against the kind of activist architecture scene, and so the idea that architects can transform things by engaging with human issues is, I think, a futile ambition, and this theory is maybe the most convincing theory, although we cannot really prove it, about the fact that what architects do is not to operate on the communities, but to operate on the physical nature of cities. So, and by operating on the physical nature of cities, we are able to transform things effectively, as opposed to try to engage into things that are perhaps outside of the discipline. So what Jared Diamond says, and this is also a theory that very much goes against all the kind of post-colonization, decolonization approach that many of these activists talk about. So what Jared Diamond says is that the reason why European cultures spread faster than other cultures, and here, I mean, I would like to say it's probably Eurasia that we would need to talk about, is because Eurasia had a dimension on the horizontal dimension that is larger than any other dimensions of any other continent. It's a very kind of peculiar theory, and so he believes that the reason why Eurasia was more successful perhaps than other cultures to, in a way, colonize the world or spread in the world, was because people could move along the horizontal dimension for a much longer distance than people in Africa or in America. So that gave Eurasians in a way a more higher capacity to, without changing the climate. So if you were acclimatized to the climate in central Germany or in central Europe, you could move along a longer distance and maybe occupy or exploit the natural resources of many more places without having to acclimatize to a different climate. And that was not available to Africans or to Americans because they had to move in the other direction. So in some ways, what he says is that there is a deep connection between geography, climate, technology, and culture. That and therefore, by being able to modify that kind of geometrical, geographical structure of the world, we can actually become more successful. That's the theory of Jared Diamond. I just wanted to mention it now because this is a kind of Earth session, and in some ways it's a kind of peculiar theory, which I mean, it will be impossible to prove, but it makes quite some sense. That if settlements or human populations could move along longer distances without changing climate, they could be more resilient and more successful in some ways. And so he basically legitimizes colonization, not on the grounds of some sort of conscious, deliberate attempt to invade other lands or other people or something like that, but simply as a natural capacity to spread wider than perhaps other populations. Anyway, without talking any more about that, because we cannot really prove it, but I think, I mean, if you can also, there is a documentary made about the book Gun, Germs and Steel, where he basically talks about why European nations were more able to spread. One of the things that he says is that, for example, the colonization of South America by the Spaniards was, or the capacity to defeat the local people was obviously because they had gunpowder and they had kind of weapons that were more powerful than the Aboriginal population. But apparently, I mean, that's what he says. The real massacre of the local population was performed by germs that colonizers were carrying. So agricultural societies in Europe, but also in Asia and in the Fertile Crescent, in this kind of intermediate area, were societies that were agricultural and therefore had domestic animals. And so people were accustomed to the germs that the animals carried with them. But the populations in America and in Africa were not, because they were not yet agricultural societies, the humans were not accustomed to the germs that animals carry. So some of the germs that these people carried were the ones that basically killed, literally, vast amounts of colonized people, not because they were literally killing them, but because they were infecting them with germs that they didn't have the capacity to fight yet, because they were not cohabiting with animals. The Fertile Crescent, again, we talk about it in the water session as as the origin of urban cultures, and I think one of the immediate relationships between cities and nature is the fact that cities grew on top of agricultural settlements. So people learned to extract food in a much more efficient way than hunter-gatherers that were simply moving through the land without being able to extract food from it. So probably one of the most immediate relationships between this engagement between cities and biomass is the fact that cities require food. So the whole scenario of food security that we are looking at now in many especially dense locations, and this kind of breakdown of supply chains of food. I mean, we've talked already a little bit about this in other sessions. Is at the very origin of cities. So as you can see, basically the Fertile Crescent was a very it was permeated with rivers and water bodies that enabled to sustain a larger population, and that is why people started gathering there and started cultivating the land, and eventually became an urban settlement and made this series of cities that are the first known examples of urban structures. We are again going back. I mean, this is also part of the idea of the background of the seminar, which is that cities are connected to we need to look at urban environments going back to the arcane beginnings of the city. And what is interesting about the Fertile Crescent is, I mean, when we look at imagery, because obviously these are all reconstructions of arcane cities in Mesopotamia, but all the imagery that we have from these cities is that cities were almost like covered in greenery. So there was, it's almost like aesthetically, as if the city was literally coming out of the vegetation, this exuberant vegetation in the Fertile Crescent. Now that is a very different image of the city, but the one that European theorists or European thinkers created in the Renaissance, that actually were expelling nature from the city. So if you think about how the European Renaissance looked at the city, they were enclaves that had absolutely no vegetation, no water. So the origin of the Western city is an enclave that has entirely removed natural cycles from them. They are subject to human laws, subject to human, in a way, structures, and have entirely removed any trace of nature. And so I believe that and that's why I think that one of the things that we are seeing now is the demise of this Western idea that the city is an enclave that is entirely constructed by human structures, by human laws, by human policies, and needs perhaps to engage. So there is a kind of emancipation from nature that is at play in these earlier theories of the city. So this idea of the Western city continues over a number of centuries. And it is interesting that the first time that green reappears in cities is in England in the 18th century with what is called the picturesque episode, in which there is some sort of imagery or kind of romanticization of the ruin of the city and the re-emergence of nature and the perversion of nature back into human constructions. But it's interesting that is always related to the demise of the city, to the ruin as an image. And that idea that plants and vegetation become again embedded in the urban fabric is then expanded even mimicked in architecture. So that this is obviously Sullivan, but that idea that buildings are ornamented with natural motifs is I think part of that recall of natural entities within cities. Then we move to things that we already mentioned. The first theorists that deliberately try to reintegrate nature in cities occur they start with the hygienists movements, mostly in England in the 19th century, end of the 19th century, and become more clearly formalized in the Garden City movement, which Ebenezer Howard starts at the first early years and early parts of the 20th century, where as opposed to the slums and to the decay and the kind of epidemics that were and the lack of healthy environment that had been produced by the industrial city, Howard and other hygienists proposed that the only solution to that is to spread the city back into nature at the early 20th century. And that is collected by architects. Le Corbusier is probably one of the most of the earliest reintegrators of vegetation within architecture. The Immeuble which is a project from, I can't remember now, but early, I think is probably about 1920 or something like that, and is based on this monastery, which is the Emma's Carthusian. It's a Carthusian monastery where every one of the monks, every one of the cells in the convent have a little garden that they can cultivate and that they eat. So it's a structure that Le Corbusier visits and is very impressed with, and then he talks about the Emma's Carthusian in the project of the Immeuble which, as you can see, literally integrates gardens together with every one of the residential units designed in the complex. And obviously, the ville radius, all the idea that the city is spreading into a park, and that the city is not something that is alien to nature, is very much part of the Corbusian ethos, or the Corbusian approach to cities and to architecture. Chandigarh, I mean, the whole idea that nature has to become an integral part of the city is very much part of, particularly the later stage of Le Corbusier's career. So we have already seen what happens after Le Corbusier starts integrating vegetation into buildings again. There is the whole episode of Silent Spring, Rachel Carson, the emergence of environmental concerns in the 60s. That gives again energy to a number of projects that bring back nature into the projects. Emilio Ambast, High Rise of Homes from James Wines. This is already the 80s. I mean, I'm going fairly quickly because actually, if you look back at the history of architecture, there is not a lot of concern about the integration of greenery into the physical structure of the city. It's almost, there is Howard, there is Montfort, there is McHarg, which we will talk about it, and there is Le Corbusier, and that's it. There is not a lot of concern with the possibility of conceiving architecture or cities as a hybrid engagement between nature and artificial structures. And of course, now we are into we know that there is a kind of serious problem with climate change, etc. There are again international policies and conferences that are made in order to implement targets, global targets about cities. There is the Stern report about climate change. The whole idea of the carbon footprint is very much part of where we are now, and in some ways the reason why intuitively, I think, many architects today are starting to think into the possibility and to practice the possibilities of reintegrating biomass into the otherwise entirely artificial materials that we have learned to use in architecture. So there is Patrick Blanc. I would just kind of show you recent examples of these things, that the idea that we can make walls made out of green, that Blanc has been practicing already for some years. Again, Patrick Blanc with Edouard François, Lacaton Vassal. I mean, Stefano Boeri. I like, for example, this as a kind of image of how literally green is going to be used in the near future, probably as a building material. I mean, maybe some of these experiments are not are cosmetic. I mean, there is a question about what is the real efficiency. There are many critics that say that this is not sustainable as opposed to being sustainable. the jury is out for a decision. There are cities that have, like Singapore, that call themselves the city of the vertical green, where greenery has become a very deliberate and integral part of the planning policies of the city. With actually, I mean, this diagram that I'm showing is probably 15 years old, and is part of the green policies of Singapore City, the URA in Singapore City, and it has produced a whole generation of buildings that are incorporated greenery. And then, I mean, it has become a little bit of a joke. I mean, and now you see, I'm putting them in a slightly ironical way, but this is the imagery that is coming out of these ideas of reintroducing green in the urban structures. These are obviously visions. They are not real constructions, but some of them are already built and they are actual constructions. And farms, urban farming is one of the things that is, or the sceneries that is becoming more common into new forms of urban planning, and there is, in a way, that an entirely new idea that has been present already for a decade, maybe over a decade, of green infrastructure. So if infrastructure in cities was traditionally made by transport infrastructure, highways, bridges, industry, etc., but now there is a new type of infrastructure that we have already been talking about, in Cheongju, etc., where parks were part of the city already for some time in England and France and a number of people. So in some ways, urban planners and landscape architects were looking at these things, but now there is an increasing pressure of cities to treat green as an infrastructure that is necessary for the survival and the functioning of urban structures. And there are all kinds of ideas about the density and the quality that different types of vegetation will need in order to pervade the city and to establish what the literature in this area calls the green to gray continuum. So if you remember that image of the cities in the European Renaissance, where there is a wall of the city that limits nature and limits the city. So there is a kind of very precise delimitation of the artificial and the nature. What we are seeing now is the opposite. It's a kind of blurring of the borders of the city and the pervasion of the urban fabric by biomass, by green elements. But as we saw already in the session yesterday, every square meter of the Earth surface is struck by 160 watts of energy per day. So 160 watts of energy free per square meter of city is coming onto the Earth, and that's why Elon Musk is going around saying that the energy that we are getting from the sun is enough to power everything if we are able to use it. But at the same time, if cities, as we saw, green canopies or green covers of of cities are a very good way of reducing heat island effects, reducing the absorption of that energy by the physical artificial structures of the city. And that's why we know now, because we have thermal cameras, that vegetation is one of the things that we can do with urban surfaces that will be more effective at reducing this effect. We have mentioned briefly in the air session Albert Kratzer, who was an urbanist and a theorist in Stuttgart in the 30s, which is the first, probably the first person who started envisioning this idea of urban infrastructure, locating parks in strategic locations in the city, bringing water bodies or water streams inside of the urban fabric in order to improve the microclimate in cities. So what trees and vegetation do in the city is to produce evapotranspiration. So there is evaporation that occurs naturally with the water that comes from the rain and is absorbed by the surface layer of the soil. But what trees do is that they transpire, so they absorb part of the water of the ground and spread it, contributing to the maintenance of natural humidity levels in the urban environment. And trees also do one very important thing, that is that they turn solar energy into and water into sugar, into carbon, basically. And that's why they become carbon traps. That's why they absorb carbon at the same time as they evapotranspirate. So the carbon cycle is one of the things that we need to understand. And the carbon cycle is that in the atmosphere, in the crust of the earth, there is a certain amount of carbon, and that carbon transforms over time. So it goes into the ground and then evaporates into the atmosphere and goes back into the ground, and vegetation is the crucial device that keeps transforming an inorganic material, which is carbon, into organic matter. So the carbon basically constitutes between 40 to 50% of the dry mass of trees. So if we were able to weigh the biomass that is contained in trees, 50% of the biomass of the trees, more or less, is carbon. And that's why trees become a crucial element of organic matter. And at the same time as doing this, obviously trees are, or in performing photosynthesis, trees are liberating oxygen. So that's basically why life is possible on Earth. So the carbon, I mean, this is we saw this diagram yesterday, but you have to imagine that 45% of the carbon in the atmosphere is contained in the organic matter that is present on the soil. So by placing asphalt, or making asphalt, or mineral materials part of the ground of the city, what we are doing is to kill the possibility that carbon is absorbed in the soil of the city. Then there are the roots of the trees, which is 13% of the mass. 40%, 50% is contained in the trees and the trunks and the branches of the tree. This is just to give you an idea of what these agents, non-human agents in the city, are doing in terms of producing oxygen and absorbing carbon. One of the biggest problems that ecosystems have today is what is called soil depletion, which is that soil stops retaining water, and that's very much the fact that takes place in the ground of the cities because of this mineral quality that we have adopted as the default solution for urban grounds, and so that also avoids when there are not sufficient trees. The carbon cycle is stopped. That's basically what cities do. They block the carbon cycle, and that is one of the biggest impediments to reintegrate natural ecosystems into urban ecosystems. And we've already seen this or mentioned this in other sessions. Now there are a number of technologies that are actually trying to retain water in the soil, make the surface of the soil permeable, so that the water can be absorbed and can be purified and returned to the aquifer. So there is the carbon cycle, but the carbon cycle is obviously very strongly connected to the water cycle. And we saw that the other thing that cities do, and this kind of hard pavement asphalt does, is to produce water runoff rather than water absorption into the soil. And the concept of the sponge city, and this is actually the first patent of a green wall. It was patented by an American scientist called Stanley Hart-White in 1938. And since then, obviously, we have created technologies that are well known, that enable us to treat surfaces of buildings with vegetation, and that has become also an integral part of policies. I don't know what the policy about green roofs is in Seoul, for example. Maybe there is not such a thing, but for example, Tokyo has a very strong policy of promoting or demanding the construction of green roofs, or the incorporation of green roofs by law, by norm, or not, I don't know if it is a law, but it's a regulation that buildings of a certain kind need to have green roofs to be able to absorb water, the same way that water is absorbed on the surface of the ground, can also be absorbed on the roofs and the walls of buildings. And this whole thing is also related to another concern, which is the concern of food security. So one of the thing that has emerged from this maybe breakdown of supply chains is that cities are obviously, because of the density of population, they are entities that constantly have to bring in resources from the hinterland, and that is now, I mean, the hinterland of global cities like Seoul is the world. I mean, you get vegetables from South America and from everywhere. All this stuff are being flown in at a very high cost, ecological cost. But now it's not only the ecological cost, it's literally the geopolitical cost that rely on food coming from other places may have on on urban entities. And that's why, the whole emergence of urban agriculture has to do with this consciousness that the city needs to try to somehow build food security for the population, and obviously that is maybe impossible to achieve because a city like Seoul cannot possibly grow inside the food resources to feed the population, but the closer these food resources are to the city and the more they become incorporated into the urban fabric, obviously the higher the food security is going to be. So there are all kinds of technologies that are being experimented with that turn these urban orchards or urban gardens or urban farms into increasingly sophisticated hydroponic technologies that enable to grow biomass inside in a very dense environment. Singapore is probably the leader in developing these technologies precisely because that problem of food security, because they are now a very wealthy urban enclave that entirely or has entirely relied on supply chains coming from Malaysia, which is at the same time sometimes an enemy, a kind of political enemy. So they, because they don't have any land to produce the food resources, they are starting to think very hard about how to maximize the amount of food that can be grown in such a dense environment, and they are making things like this. So this is almost like a wheel that keeps moving the planters up so that they get sun, and then they come down and they are put through a pool that lies at the bottom of this kind of wheel, so that the planters are watered, and the water also contains fishes. So they are experimenting to almost synthetic vegetation devices that could at least improve to some degree the food security in the city. So these are built examples. This is not theoretical. It is actually happening in Singapore now in places like this. So there are greenhouses that absorb the energy from the sun, and then they contain these wheels of planters that produce green for human consumption. The other thing that is becoming also an interesting technology in terms of food security is algae. So algae is obviously a very nutritive biomass that can be easily cultivated, and so there are now also experimenting with algae farms as another source of food security. I mean that happens in dense environments, but also this is I think a project in the US, but the idea that you can cultivate biomass either for food security or even for biofuels. I mean, one of the potentials of algae is that they can easily convert it into fuels that can power the city, and there are all kinds of now technologies that are being developed even to lit surfaces using what is called luciferin bioluminescence. So basically, instead of having lampposts in cities, you can have trees that are provided, and they are actually artificial trees that become collect the light, like some algae do also, and at night they emit light, and they can basically lit urban spaces potentially. So these are maybe some of the possibilities that are being opened now in terms of this reintegration of biomass into urban structures. There is the other. So we talk about the carbon cycle in the session of water. We talk about the water cycle, or the hydrological cycle. But there is another cycle which is the nitrogen cycle, which is also integral to the growth of biomass, and we have already mentioned it briefly. But this serves as a, I mean, this is actually the main location of this part of the seminar. But nitrogen was, I mean, nitrogen is also a free flowing element in the atmosphere, in this kind of Earth crust, and so there is a cycle in which nitrogen goes into the ground and goes back into the atmosphere, and that moment in which it goes into the atmosphere, or the moment in which nitrogen has a kind of gas form, and it becomes fixated by a biological process which is performed by plants and animals, is what is called ammonification. We talk about the synthesis of ammonia. So the synthesis of ammonia is basically an artificial process that does this. It fixates nitrogen into a solid material, a physical material, which is ammonia. And this is what Liebig, I also mentioned it briefly, but Liebig was a scientist in Vienna in the 19th century, which was the one who announced for the first time the law of the minimum, which is basically the principle that biomass growth is dictated not by the total resources. So the total resources, we know that carbon constitutes 50% of the biomass, and so nitrogen is only 6% of biomass. And so Liebig says the amount of biomass that can be grown at any given time depends on the most scarce resource. So while carbon is widely available in a form that can be easily incorporated into plants, nitrogen is rare. And so what Liebig says is if we were able to have a wider amount or a larger amount of nitrogen present, we would be able to increase the biomass. And so this is why after Liebig announced the law of the minimum, many scientists in the 19th century started thinking, okay, so how can we make artificial ammonia, how can we mechanize, how can we engineer the process of the synthesis of ammonia? So everybody knew that if somebody came up with that technology, we would be able to expand the growth of biomass to a much larger scale. And so the nitrogen cycle is actually much more complicated than the carbon cycle, and we're not going to get into detail. I'm just simply dropping this stuff. If any of you becomes interested in that, you can Google it or you can look for information about it. But as I said, the guy who basically comes up with the solution is Fritz Haber, which invents the synthesis of ammonia in 1906, and develops it with Bosch, with the Bosch, the German manufacturer. Basically understands that this is a very important thing, and so they develop what is called the Haber-Bosch process, which is a process that engineers the synthesis of ammonia by consuming actually quite a lot of energy, but using this is the kind of earlier version of the synthesis of ammonia using the Haber-Bosch process, and this is what is the production of phosphates, of fertilizers, which we saw that this diagram also yesterday, that have an exponential growth globally. So, and that basically constitute, because basically humans consume vegetables which contain sugar and carbon, and we feed ourselves with this kind of stuff, and this is basically what has enabled to sustain a human population on Earth that is much larger than what natural nitrogen cycles would allow. And this is why Smil says it's the most important invention in the history of humankind, because it has enabled humans to double their biomass on Earth. So you can. I mean, this is a modern fertilizer plant that I like to look at these pictures as human factories. I mean, we are made there, whether we believe it or not. We are made in these places, because that's what enables us to survive. Fertilizers are made in different places, and they are dangerous stuff. They are highly toxic. I mean, the center in the US is New Orleans, which is also the highest cancer rate in the country by far. They have further, I mean, some of the guys who became rich with fertilizers are the Koch brothers. You know who the Koch brothers are? No? They are very right-wing Republican donors in the US. There are two brothers. One of them already passed away, but they are devious people. And one of them actually, they became so wealthy because they developed a more efficient technology, a patent, to produce fertilizers using less energy. The diagram from Smil showing the amount of energy that was consumed in the early versions of the Haber-Bosch process has reduced, so now it's much cheaper energy-wise to produce fertilizers, and partially it's due to the Koch brothers. So you see, Koch Nitrogen Company, 12.4% of the market share in the US. But you know, they are also ammonia is a very powerful explosive. The explosion that happened in Beirut that basically blasted the whole harbor was actually an ammonia deposit. So and Smil has a very, I think, interesting image that he talks about in his book, about these rice fields in China that look bucolic and and natural and so on and so forth. Well, and you know, this kind of imagery of agriculture and so on, but this stuff now in China is full of fertilizers. China is basically the biggest consumer of fertilizers. You can find SMIL has several statistics about this, but depending on the country, you have more or less percentage of the agriculture sustained by fertilizers, and in China it's huge. It's I think 60% or something like that. In the US, I remember it was like 25%. So yeah, but mostly underdeveloped countries are the ones that are now using the highest amounts of fertilizers. They're the most depending economies on fertilizers. And obviously industrial farming is also using this technology in order to increase food supply, which in some ways is good because it has eliminated almost not entirely eliminated, but reduced enormously the hunger from the world, but at the same time is a very toxic because it also produces the eutrophication. It distorts basically the nitrogen cycle and depletes the soil from the capacity to engage in this processing of nitrogen. So I think this is something. I mean, I don't know to what degree is relevant to architecture. But I think it is important for us to start understanding that one of the things that cities do and urban populations do is to distort these carbon cycles and nitrogen cycles, which are chemical cycles that occur naturally in the atmosphere. Perhaps another take into this re-engagement of cities with natural cycles is biodiversity in cities. So these images of eagles populating the reveals of New York buildings are probably an interesting image that illustrates this idea that there are certain animals also that cities have expelled, and actually biodiversity, as you may have heard, has killed like 50% of the species or humans have killed 50% of the species on Earth. And so now there are a number of policies that are starting to change that or to address that question. One of them, for example, is the idea of creating natural highways. So a highway is a very harsh action on the environment because it cuts the possibility of worms and animals, rabbits, snakes, all kinds of guys to move across the land. And so one of the things that you see now happening in developed countries, in sophisticated countries that are concerned with the natural environment, is the creation of these the assurance of these nature highways, these paths that are enabling animals to move across these artificial borders, for example, by vegetating bridges. So this is made by, this is Switzerland, Germany. Some of these countries are very concerned with this issue of biodiversity and the possibility of ensuring that there is a system of natural highways that enables animal populations to move across the urban or the artificial structures. This is, for example, the European Green Belt, which is interesting because it's a project that extends over 8,500 kilometers. It goes from Finland to Greece, and it actually grew out of the fall of the Berlin Wall. So when the Berlin Wall stopped, there was a land that had been preserved in a natural state because it was a security line. It's like here in Korea, the border with North Korea, which I have read. I mean, you probably know much more than me about that, but it's a natural reserve because it has been untouched by humans for decades. So the same thing happened with the Berlin Wall, and now there is a European-funded project which is to preserve this strip of land as one of these natural highways. So when we talk about urban green infrastructure in cities or in the territory, probably we can look at some of these processes that originate in geopolitical conflicts that have kept land untouched for a long time. So I mean, what we see now is the emergence of those kinds of policies that ensure continuity of green across the city. So it's almost as if the city has to be permeated by nature, by policy. I mean, like there are rules now that are starting to appear that preserve the continuity of these green paths or green highways across the city. And so these are different examples. In Florida, the wildlife corridors, in Buenos Aires, in China. Anyway, I'm not going to talk about them in specific, but this is one of the let's say of the things that are happening that we could be thinking about when looking at the city. It's almost as if the city now has to identify paths where nature can be preserved across the land. Ian McHarg, a disciple of Louis Mumford at Harvard, born in Scotland, and basically was the guy who made the UPenn landscape architecture department, wrote this book, which I also recommend you, Design with Nature. Started talking about these things already in the 60s. So he basically is, I mean, Mumford was a disciple of Howard, and Ian McHarg, who is actually engaged, or was actually engaged with architecture, with landscape architecture, was a disciple of Mumford. So there is a kind of lineage between the garden city tradition and the hygienist traditions in England in the late 19th century till this day, through Ian McHarg, which is interestingly one of the places where landscape urbanism started. Are you familiar with the landscape urbanism scene? You have heard about landscape urbanism as a kind of new urban theory that was very popular in the 90s. I mean, basically, my generation was very much part of that scenario, and UPenn, James Corner was one of the main agents, and Jim is also somehow inheriting this tradition of Ian McHarg. OMA, Remkulha's project of La Villette as also some of the projects that perhaps in the 80s started to think about parks and urban green urban infrastructure. But even more interesting than La Villette from OMA is this project that I don't know whether you know, which is the Melunsenart competition. It was a lost competition made by OMA, I don't know, probably early 90s. I can't remember now the date, which basically identified or decided that the only way to plan this peripheral village around Paris, Melunsenart, was to decide what areas will not be built on. As opposed to planning, like everybody else in the competition was trying to plan, to propose physical infrastructure, so Rem decided that he was going to just decide what are the areas of the city that are not going to be built as the main idea. And in some ways, this is part of, or is a premonition of this idea of green infrastructures or natural highways that are crossing the space of the city and bringing back into the city the natural environment. So I already mentioned landscape urbanism, and Ian McHarg, and after that Jim Corner and Charles Wildheim, who is the head of the landscape department at Harvard, were all part of that Penn based theorists that proposed that the urbanism of the near future, I mean in the 80s they proposed that the urbanism of the near future was going to be about landscape, about nature, and about the reintegration of nature in the in the city, as opposed to the idea of a hard architectural artificial planning of cities. And I mean, the whole thing of landscape urbanism is mysterious to me, mainly because I think it was a failed project. I mean, I don't know now. At some point, it was a very important scene in the discipline that nobody has continued. I don't quite understand why. Maybe we can discuss this in the in the session after my talk, but basically there were two interesting things about the the idea of landscape urbanism, and they both relate also to the Melunsenart project from OMA. This is a diagram that was made by James Corner and Stan Allen in their competition entry for Downsview Park, which was an important competition that happened in the early 90s, in the late 90s in Toronto. It was not built. Actually, we were part of the shortlist also, so we entered the competition. But there were two things that were or are important about this integration or reintegration of nature into the city. One of them is the temporal dimension of urban design. So while traditional urbanism is almost fixed on a single time scene, I mean, there are phases, so you build cities in phases, so there is a kind of, but there is a kind of final picture that is decided at one moment, at the moment in which the master plan is made. And as opposed to that, this idea of bringing back landscape or nature into the city introduces a temporal dimension, because obviously nature is a process. Nature is temporal. Trees grow, parks grow, as opposed to artificial construction that are made and crystallized in one mineral moment. Biomass is something that is constantly evolving. It is constantly subject to these carbon cycles, nitrogen cycles, water cycles. So everything is constantly in movement, and this is part of this. This is why I like this diagram as a very good example of the idea that the design of things when integrating or reintegrating natural processes into the city is temporal, is subject to a temporal dimension, which was also, by the way, present in Melunsenart, in the project that I mentioned before from Kulhas. This is another entry into the Downsview project, which was the entry from Bernard Tschumi, which was not, I don't think it was interesting at all, but it has one very important, I mean, I selected this drawing because I think it captures very clearly another idea of landscape urbanism, which is the diffusion of the figure ground image. I didn't have, when I was preparing this in a cafe, I didn't have internet, and I wanted to bring in an image of the Nolly map. You know the Nolly map? So this kind of black and white representations of the city that are very much part of the way in which traditionally we have planned cities. So there is built stuff and there is empty stuff, and it's black or white. And I think one of the things that happens when we consider the urban ground as a bioactive element, and that pervades the artificial ground, is that this black and white image of the city disappears. And this is what I like about this diagram. I'm now talking about almost like things that we do as architects in order to enable the design of these processes. Is the kind of erasure of these hard borders between the artificial and the natural. This is another drawing that in some ways is very much part of these graphics of landscape urbanism. This is Charles Waldheim, that also show that the city is almost formless. Melunsenart was also to some degree formless. There was some sort of resonance with some sort of Chinese character that was not understandable by Western people. That was very intriguing about that project. But that idea that the plan of the city cannot be easily understood and is constructed through a series of complex orders was very much part also of the tools that landscape urbanism started to develop. And so the biggest enemies of landscape urbanists were in the States. I mean, this is maybe also an American discussion. But you have heard about new urbanism, right? So new urbanism is also using trees and using vegetation in a kind of more conventional or verified state, and I mean, some of the landscape, the new urbanists, or the original new urbanists are Andres Duany and Elizabeth Platter-Seiberg, who, and obviously the Kriers and a number of other people who started to say in the 80s that the cities could not be planned with highways and high rises and entirely artificial stuff. So there is a kind of interesting relationship between landscape urbanism and new urbanism, which revolves around the reintegration of nature into the urban fabric. Which, I mean, these two guys are literally, this book, Landscape Urbanism and its discontents, is written by Andres Duany after the landscape urbanism episode. So Jim Scorner and Charles Wildheim and all these guys propose a new type of urbanism that is almost formless and figure groundless and integrating biomass into the physical mass of the or mineral nature of cities, but there is a curious convergence between both scenes around the reintegration of nature into the city, and so these are maybe examples of these new urbanism. I think what is interesting about looking at these plans and these graphics compared to the graphics of landscape urbanism that we were seeing before is that here we do have a figure ground relationship. We do have, but it's a figure ground relationship, but now we have black, white, and green, as opposed to black and white. And these black, white, and green are structures that, rather than being divergent or discordant, are convergent and consistent. So the trees are reinforcing the urban, the street alignments and the building facades. And I think that it is quite clear what are the tools that these two forms of urban design that I think in some ways construct the current debate of urban planning, whether we like them or not. So the idea that the city is reincorporating this biomass can be implemented in many different ways, and the two paradigms have been produced in the 80s or the 90s, between the 80s and the 90s, and I don't know whether there has been a clear solution. Landscape new urbanism has been incredibly successful in the States. I mean, literally, the contemporary planning of the state in the US are very much based on what the people from the new urbanism said. They were, you know, they are making many of the new cities in the US are based on some of these theories of escaping from the highways and the suburban structures, and I believe that the reason why they are successful is that they make sense. People like to live in these cities as opposed to live in suburbs, and these cities, whether we like or not the design, are more ecological, are more capable of producing an urban microclimate that is sustainable than the cities of the produced by modernist planning. I mean, this is the kind of environment that this new urbanism has produced, and you know, you can think that that is a decent city. That, for example, I mean, maybe one of the reasons why landscape urbanism failed to succeed and was somehow discontinued is that it didn't produce a legible urban environment that people could easily relate to. It's almost as if you are designing a car, no? You are designing a car. Somebody could come up today with the idea that the best way of designing a car is to have the steering wheel in the axis of the car, because you know it's in the center. You're driving, but the whole system is now designed so that we drive in two directions, and therefore it makes sense that the steering wheel is in one side of the car instead of in the center of the car. Like, you know, in science fiction movies, sometimes the steering wheel is in the center of the car. So if somebody, like, in my view, landscape urbanism is this idea of figure ground, the disappearance of figure ground produced designs that were complex and not understandable by people. So people can relate to these new urbanism cities because they've seen these cities before. And landscape urbanism could not produce an urban structure that was easily engaged by people. So it was a kind of theoretical proposal that was very interesting, that was probably very representative in plan, in theory, about this reintegration of biomass into the physical structure of the city, but didn't produce designs, actual designs that were viable because of this inherent complexity that it had. That's my theory. I think that we can. So this kind of cities, which maybe we don't like or we like. I don't know whether you like it or not. I don't like it, but I mean I don't like what I see in the image, but I think that if you remove the design of the architecture, maybe is okay. It's a livable urban environment that has a certain amount of greenery. This is the city that new urbanism has produced in the US and maybe in other places also. I mean, like somebody who took the new urbanism ideas into some sort of hardcore planning theory is Peter Calthorpe, who is an urbanist based in California and that has made huge amount of projects all over China. I mean, probably he has done also something in Korea, but that has basically exploited that idea of the convergence or the consistency between green structures and traditional figure ground urban structures. And you know, even kind of axial schemes that, you know, a landscape urbanist would hate this plan of the city because it doesn't have any complexity, because it doesn't respond to what landscape urbanists or people like me who were connected to that idea were interested in, which is almost the dissolution of the image of an ordered city into some sort of natural naturally looking structure. I am actually surprised. I'm walking around the campus these days and other places in Korea. There is an interesting neo-natural approach to landscaping here. Like on all these rocks that are kind of, it's almost like, how do you call the rusticato in Italian? Which is maybe a kind of early form of integration with between. Do you know what the rusticato is? No? Do you know the Palazzo Strozzi in Florence? The use of rough rocks into sophisticated buildings. That you know, they look like rocks taken out of nature and brought into the building. And it's interesting that many of the landscape design that I see around this campus, certainly, but also in other places in Korea, has this kind of natural quality that is not like a French garden. I mean, the French garden is very much part of the idea that nature has to be tamed and has to be ordered based on almost artificial orders, geometrical orders, but nature has this kind of complex, formless quality, and I think that conflict is at the back of this querelle, this controversy between new urbanism and landscape urbanism, that whether we like it or not, and I'm saying this in a way as part of the landscape urbanist generation, we've lost. We had perhaps the imagery or the kind of theory that supported a certain form of reintegration of the nature into the urban fabric, but I think that generally speaking we lost. But when I look around the campus, I see that there is some sort of latent desire of naturalizing the artificial environment. That is almost like kind of latent desire. Is something that exists in people here in Seoul, perhaps because the city was built in such a brutal way and such a kind of ruthless way that killed the natural environment and somehow is resurfacing, maybe on a cosmetic level. But for me, these are also interesting. I mean, beyond understanding the food security issues and beyond understanding the carbon cycle and the nitrogen cycle, which I think are important for us to understand, if we want to conceive I mean, if we think about the things that I've presented, no? Carbon cycle, nitrogen cycle, natural highways, green infrastructure, all these issues are maybe food security, are concerns of contemporary concerns about the necessity to reintegrate urban orders into the artificial environment. But how do we solve that question? How do we design that reintegration is up for grabs. And at this point, I would say this is winning, at least on a fundamental level. But I can see when looking around here, some sort of latent desire, perhaps for structures or geometries that are perhaps more reminiscent of the formlessness of natural structures. So that for me is the question. Maybe we can discuss this now. This is the latest slide in the presentation today, so we can continue and maybe discuss these issues now.